Welcome to KT Study Zone. In this video, we're going to talk about the atomic structure. This is the first part in the unit Structure of Matter. Before directly jumping into the atomic structure, let's go through an introduction. Well, things in our environment can be classified into two main categories, as matter and energy. Matter are the things that occupy a space and have a mass. We will discuss about matter in detail. Energy are the things that do not occupy a space and do not have a mass. For example, light energy. Now let's see about classification of matter. Matter can be classified into three main groups according to the physical nature as solid, liquids, and gases. You know about this, right? Matter can also be classified according to the chemical composition into two groups as pure substances and mixtures. Well, pure substances again can be classified as elements and compounds. Examples for elements are iron, oxygen, copper, nitrogen, and there are so many. Examples for compounds are water, carbon dioxide. Well, mixtures on the other hand can be again classified into two groups as homogeneous mixtures and heterogeneous mixtures based on their composition in a unit volume. Examples for homogeneous mixtures, salt solution, sugar solution, and heterogeneous mixtures, lime water, rice and sand. We'll be discussing about these in detail in future lessons. Alright, now let's get into the atomic structure. Atoms are the building units of matter. Well, these atoms are composed of three main subatomic particles called electrons, protons, and neutrons. Electrons are negatively charged, protons are positively charged, and neutrons have no charge. Well, electrons have a very small mass. If we consider the relative atomic mass, it's 1/1840, and protons and neutrons, the relative atomic mass is 1. Anyway, the neutrons have a slightly higher mass than protons. Now let's see about atomic models. As a result of the effort taken to describe how subatomic particles are organized in matter, atomic models were introduced. Earlier in 1897, J.J. Thomson presented the plum pudding model, in which he explained negatively charged electrons are embedded in the positively charged sphere of the atom, as how the plums are embedded in a pudding. Breaking Thomson's ideas, in 1911, Ernest Rutherford presented the nuclear model. Well, as it says, there is a very small area called the nucleus with concentrated positive charge at the center of the atom. If the atom is a football ground, nucleus is very small volume, even smaller than a chickpea at its center. So you can clearly understand that nucleus of an atom is very small relative to the size of the atom. Protons and neutrons are accumulated in this nucleus. Well, nucleus is hence positively charged. Electrons revolve around the nucleus of the atom. Well, the number of electrons in an atom is equal to the number of protons, and also protons and electrons are oppositely charged. Therefore, atom is electrically neutral. Electrons revolving around the nucleus of an atom is similar to the solar system, where a planet revolves around the sun. So, this model is also known as the planetary model of the atom. Even though the electrons are attracted by the positive charge of the nucleus, they do not fall into the nucleus. This is because electrons revolve with very fast speed around the nucleus. In 1913, Niels Bohr further elaborated Rutherford's model and presented the Bohr model, in which he says electrons move in definite paths or shells around the nucleus of an atom. Well, these shells, also known as energy levels in which electrons revolve around the nucleus, are assigned either in numbers 1, 2, 3, 4 or in letters K, L, M, N and so on, respectively, starting from the one nearest to the nucleus. Each energy level has a specific energy. When moving away from the nucleus, this energy increases, which means first energy level has the lowest energy and the last energy level has the highest energy. But the difference between these energy levels keep decreasing, which means difference between first energy level and the nucleus is the highest and the difference between last energy level and the before one is lowest. In an atom, there is a maximum number of electrons that can be carried in an energy level. As shown in this table, in the first energy level, it's 2, second, 8, third, 18, fourth, 32. That's it. Hope you got everything and enjoyed the video. So, subscribe!